Oh my
Hello.
God, what happened? Who is that man?
This is Ed
What?
Fullman, and
Okay.
I'm here with you today.
Are you
Uh,
sure you are you?
I'm
It's Ed.
sharing me um, due to requests from our fans who have seen pictures of me in my goggles. We're gonna try to do this with me in the goggles. So a little backstory on this: if you've seen some of um, the videos I've done, I got these goggles, I guess, a couple of years ago now. These are Meta goggles, and I use something called Immersed to create virtual spaces. And basically, what I'm seeing, you can't see it, is a wraparound screen that's about 6 feet high and goes all the way behind me,
Wow.
with all my stuff on it. So just to keep in touch with our dorkiness, I'm wearing this to kind of add a little bit to what we do every day. But
I will have to learn to do the same. You feel so immersed.
I am so immersed. So anyway, we've got a good plan for today. Talk about some cool stuff. Our One of the things that we've been thinking about for this episode for a while is to talk about some of the decision making people that are planning on using Kubernetes have to do. Some things that we've had to decide over the years, as far as whether to use a service like EKS or AKS, or to roll our own with K3S or RK2 from Rancher, to get a Kubernetes solution that we want. And like, what are the reasons why you want to go down that road? What are the constraints? That's what we're going to talk about today. And at some level, you could throw out that there are multiple answers. Maybe not all answers are the right answer, but there are multiple answers for multiple situations. And I think the thing you and I have seen, Fab, over time is that sometimes your needs change, or sometimes your constraints change, and that can be driven by other things in the environment other than who the cloud provider is or whether or not we want to use their service. It could be business constraints that pushed us in a direction, and it changed over time. So I know together, you and I we've used EKS on Amazon, and um, we've used Rancher that we set up um, on Amazon. So we've done kind of everything I think we're talking about, which I think is another good reason for the topic today.
So again, I will ground the discussion technically for everyone that is listening. And this is not about AWS versus Azure versus Google Cloud or whatever you want to call K3S. We will talk about all of these things, but not as a battle. It's not something that is deterministic in this case, but we are going to look at actual workloads. So, what is the effective use case, and we map that in the right platform. That for me, in this case, is Kubernetes. So just think about that, but it's not a favorite one. There are no specific things that will really work generally. It's not um, hands-on manual or a Swiss knife. We are going to consider all the scenarios that you were mentioning, Ed. So latency, costs, regulations. I will do the nuts and bolts view while you are going for the workload concepts.
So let's get into what's driven our constraints over time. right? Like what helped us make a decision about where to go, compliance, time to value, um, realities of hiring people to do things for us, and build things for us, and just how that drove a lot of decisions. Uh, what do you think? I mean, what do you think of when you think of some of the constraints?
When I think about that, Ed, I think that we have to consider timing. So, in example, the first thing that one will look at will be how much time do I need to get a response or a specific behavior. And here I would differentiate between edge, on prem, and cloud, because in cloud you can have more latency. So it's generally in the order of 10, 40 milliseconds, while on edge, on prem, you have less. You have 10 milliseconds that are acceptable. So the first thing to look at is the differentiation of the tolerance bands that we are isolating here for the two workloads that are our targets for today. Then we have to think that we have stateful application, stateless application. Just to give a brief introduction about that for who is not familiar with that, think about stateless as web, API, front ends, something that is elastic, portable. You don't have a disk that is attached to a stateless application, while stateful is similar to databases. If you have machine learning training or something that will use GPUs and you will need a disk with a sticky architecture. So in that case, both are also adding constraints to the architecture that you are implementing. And then in the current days, we use a lot of AI and GPU for whatever. It was used for mining Bitcoins, then it is used for the machine learning patterns and training, and today also with AI and tokens. So training jobs generally may need GPUs near data, and that means that you have an additional constraint that you can um, cause your architecture to be sensitive to these kind of things. And also inference jobs for the GPU generally are live in cloud, while if you use them locally, you have to implement the right strategy. So another constraint that I would consider is the connectivity. It could be intermittent, breaking assumptions. And you remember that at the edge, we had a lot of problems because of intermittent connectivity, especially when you go to several customers that are having different providers, that they are geolocated in different positions. And that is complicated and it's part of a constraint. I think that I covered more or less what would be the scenario for a workload.
Yeah, I think from the business perspective, these issues, these constraints, they're enormous. They're big swings in cost too, from how you're going to approach them.
Do
But
you think that, one thing also that I was forgetting, the shifting decision that generally is coming before technical details. So I mentioned all of those constraints, but
yeah,
you are talking from the business perspective. Probably those constraints will sound familiar if you think about something that is coming before the technology.
yeah. I mean, for me, I think driving whether we got to be on prem or whether we don't have to be on prem with edge devices, it's a big deal, but it gets into like the value proposition of the overall architecture, right? So, we needed rich ecosystems. We needed, to get something up quickly. Um, we needed to be able to pass audits, which all led us to kind of hyperscalers that could support us by giving us their standardized offering. But like everything else, there's a trade off for that much standard platforming, right? There's things that you can't do. And, this is what we've seen before is the constraints kind of pull us in multiple directions at the same time, right? They pull us towards something like stateful versus stateless, and then at the same time we've got to like deliver some kind of serverless infrastructure or GPUs or something that drives us to like pull the architecture in a different direction.
You mentioned hyperscalers. Each time that I hear that hyper parameters, hyper speeds, I don't know what that this hyper is describing, but they are generally scalars, finally, and reducing the hyper. They can be the right call, I think, in business. But if I have to talk about them from the technical perspective, if I Google, I will find almost nothing. It's more the experience that is giving me the ability to differentiate what are the strengths of some solutions. Like an example, you have EKS, AKS, GKE, whatever more um, assisted type of hyperscaler that is having managed control planes. And this is a big difference because if you think about K3S and what you deploy or Rancher, whatever, RK2, you will manage your own control plane. In the case of the solutions given by the providers, they manage for you the control plane. And I think that that's for business. It's a game changer because if you don't want to dedicate a full team to maintain that hyperscaler, that will be great for speed to market. You will be immediately going there. And then you have rich ecosystems like serverless, AI, machine learning, analytics. There is no need for reinventing. It's everything available. And compliance and audits are also integrated with regulations and whatever we need to use for those acronyms SOC2, HAPAA, and whatever more you want to mention, GDPR. These are all strengths of the hyperscalers. While I see limitations also from the technical perspective, that is an example, like a Kubernetes certified man, updating and patching the node. That's a pain always. And you have to manage the add-ons. The more that you add, you will have to handle basically your own service level agreements. And it's a limitation for hyperscalers that you can also pair to the vendor lock-in risk. If you are using those solutions like EKS, AWS, and similar, you're not vendor locked, but you have less problem on SLA. You have less problems on maintaining the network that we saw is a constraint. And billing is easier because you just pay the invoice. You have to check costs. I think we will pay later attention to these kind of things. But I would leave you, Ed, with the SaaS startup building multi-tenant analytics use case versus, in example, a company that is working at the edge with IoTs. They are completely different use cases, and it's where we have to put the attention from your perspective to analyze the business case.
Yeah, I mean, I think the reality is that if you're from a cost perspective anyway, is some of these costs you can't escape. I mean, you're going to have to run it somewhere, whether it's at a hyperscaler or your own data center or something. So those costs are going to follow, the same issues that everybody has with or without Kubernetes, right? If you're going to put it in the cloud, you're going to have certain kind of cost profile. If you put it on your own platforms, you're going to have others. You're going to have some advantages from that, which could be good. On the other hand, it's going to create a trade-off. And my perspective generally about things like K3S and RK2, when we've used those technologies, you're going to trade off standardization for control. So if you have control, you've got to have the skills to use the control wisely and be able to actually get what you need out of it. So I think as you know a company trying to put something up in production, your challenges become the staff that you have, how many you have, whether they're deep enough as far as skill sets, one on top of the other, to actually manage your own control plane, for example, and handle that whole line of thinking. If you go back to the beginning of your some of the things that we've done where we rolled our own Kubernetes with K3s, for example, we could have gone back to the beginning of that thinking and said, let's just constrain the application for Amazon. I think the challenge that you get into is platform businesses versus IT architectures and running internal applications. If you're in a platform business where you're trying to sell platform services and applications, you're in a place where you may not be able to afford as easily the cost of a hyperscaler on top of what you're trying to do. So rolling your own service, even if it's on, like putting K3s on a EC2 instance, at Amazon, becomes a practical way of controlling some costs, but you're also going to pick up costs from your team. So, this whole concept of vendor neutrality, I think it's something that can be achieved theoretically anytime, right? Like you can start down a process to be vendor neutral if you want to be. But predictable unit costs at the edge is really what you're looking for, right? You're looking to like make a plan, get people to agree with it, set pricing, and then have less surprises in the end. And I think either of these two solution sets, like something like EKS versus or K3s or RK2, really would be RK2 in the cloud. Being able to choose between them becomes, from my perspective, it's back to the staff, right? So we had the team from over time to take on some of these really complicated issues, and other companies might not have the team, so that's going to push them down the hyperscaler route versus rolling your own with, um, RK2, for example.
Yeah, you are talking about RK2 a lot, K3s. I will mention some names just to consider that we also know those technologies. We are aware of them, like OpenShift, OKD, which is the open source version, not just the providers like AWS, Google Cloud, and similar for their hosted solution. Why we chose K3s and RK2? The reason is maybe it's not the right call. Maybe it is we don't have the crystal ball. Actually, I think I have a crystal ball right there, but I don't use it for Kubernetes. So the K3s is something that is lightweight. Now there is also a Mirantis option that is K0s. They are optimized for minimal footprint, so they run in remote, low resource sites. You can survive offline or intermittent connectivity with K3s, and you can also have air-gapped environment. That is very interesting. RK2 is hardened Kubernetes, so it is adapted for running in the cloud. It is already complying with the FIPS governance and compliance requirements. It is great for regulated or disconnected fleets. It's included with Rancher, so it scales on fleet management. Then it has a storage component that is Longhorn, so it is embedding the ability of being reliable on the storage system that generally in the base Kubernetes is just a generic storage class, the default one, where you cannot expand disk, move the content from one side to the other. And if you are using stateful application, that is very, very important because the database should be paired to that disk. And it's very complicated to distribute the content among several nodes, especially when the architecture increase. The ops model, everyone is thinking about operations. I need to pay a team for operations. Generally, with Kubernetes, we talked a lot about GitOps. So you have a way where tools are really helping you, and you don't have to be a super special with the abilities to create your own Argo CD rollout or deployment, to use Flux a little bit more because you use the command line, or to integrate with Fleet. It's generally something that you do as a push once, and it's thing everywhere. And that is part of this K3S RK2 solution that is embedding already these kind of things. So an example could be a retail chain with hundreds of stores that is a sympathetic use case where you have K3S clusters in the stores, and RK2, it's a data center. It can be on the cloud. It can be your own data center. That is also a good point for virtualization. But basically, with this, you can imagine that RK, K2, K3S, RK2, we used them because they are a homogeneous solution for what we intended to work with. We are open always to look at other technologies, but let's say that the predictable unit costs become effective when you have experience on what you are using. So probably Ed, knowing what is the platform that you are going to use, I think that will imply that you know costs and billing.
Yeah, I think where this continues to carry on as far as constraints and drivers is security and compliance posture, right? So there's, this, at least in theory, shared responsibility in the cloud where, you're going to get Amazon and others with their products, their Kubernetes products, you're going to get them to provide a certain level of responsibility, um, that is going to make it easier, especially if you don't have the people, to manage, um, what your deployment's actually doing and how it's being safeguarded versus fully self-managed, where you're going to own it all and the audit burden and the evidence to show that it's working properly. So it's not even just that it works and that, you've got an ability to show it, but that you can survive an audit and have the evidence ready, which normally one of the hyperscalers would do with one of their solutions. So I think that, the constraints here that pull you in these different directions are, even if you need something one way, you'll get pulled in another, and it's laying out all these decisions and looking at them on a roadmap over several years where you start to figure out like what your actual plan's going to be. Because maybe, I mean, the way we've done things before, we started out on EKS and we ended up on our K2 and K3S. So I mean, it wasn't, those kind of decisions weren't because we didn't like Amazon or something like that. I mean, we still ran it on their hardware. So it's
We
really
like
more
everyone.
about, what we had to do, right, at the end of the day.
Yeah, and think about this security and compliance posture that you mentioned. In the technical point of view, from the technical perspective, there are some words that people will be familiar with, like software billing of material. This has become very trendy, or signing your own container images, policy as code. I see that all of these things are embeddable in Kubernetes, and using solutions like in example, the Harbor registry, you can have image signing, software billing of material. At the moment you create a container and you have the um, developers putting their code on top of a line up for for a plan for having policy as code integrated, and then finally consider what you were mentioning about identities that in the cloud are generally identity managed by the cloud providers, or at the edge, you can use additional products that are parallel to Kubernetes, like Spit, Spire, HashiCorp Vault. They are already widely used, so they are supported. There is no reason to be scared about maintainers disappearing and similar, and they are effective for the edge case that generally is not really the same as the cloud. So I mentioned earlier that this is also valid for air gap. There are people that are working in defense or healthcare where the data should be isolated from the internet. And in that case, it's really hard to be security compliant because you just think it's disconnected, so it's secured. It's not really, because generally you will need to maintain patches, updates, a lot of things that needs to be proven and that cannot be tampered with other tools or have problems on the security point of view. So under attacks or similar, they are gaps, but they need protection. And these kind of tools that we are talking about for Kubernetes integration, they provide, from the technical perspective, you this ability to see this compliance effectively at your hands so you can manage. Trust the cloud. We need to trust also the air gap. The Kubernetes instrumentation that we can use is effective for these specific cases.
Yeah, I think the other thing that we've seen constraining us, certainly sometimes surprising us from a financial perspective or an operational perspective, is networking and storage over time, right? Um, it always seems to run very easily when it's small and you're starting out and you're trying to get the first version approved or something like that into production. That's when, the networking's easy. Where it gets complicated is big distributed architectures, especially platform services with edge environments. You got to move that data around, and it's not really Kubernetes. I mean, it's Kubernetes involved. It's adjacent to Kubernetes decisions, but um, it's going to cost you, and the bigger that load gets, the more it's going to cost. And I think it's another. We're on probably the sixth topic here of constraints. The reality is these are 6 reasons for specialized skills in the organization, which drive whether you can handle this stuff or not handle it.
Yeah, generally, when you think about costs, people are always thinking about something that is affecting the billing, but they are not thinking about the causes. So, in example, mentioning network and storage, that can be surprises. From the technical perspective, having control of those components, it is very important. In Kubernetes, we have a component that is called container network interface, and generally there is a lot of arguments there that are considered for who choose what. So it's not just about RK2 AWS, it's about Calico, Cilium, Kilo, a lot of products that you can use for CNI controlling your networking, and then the East-West policy where you have service mesh in this case, open inside cluster, egress control, shadowing the traffic for basically avoiding the leak of the costs and data to be not controllable. And this is something that is very important because in Kubernetes, it means we have the right tools for controlling our network usage and also for protecting it. Network policies are an example. Then we have the storage point that you were mentioning, and there is not just the space that I'm using or the constant IO access that I am affecting my resources. So I say, well, I will not go from the cloud perspective to use all that amount of storage because I will have my own storage center. Is that just the only point? Object storage, in example, on the cloud is very cheap. But if you have locally, you will have to pay licenses for products like Mini IO that will cost a lot. So it will not be really something that you can consider as a marginal cost. And then the test failover on real data sets is enormous. It's coming out. I remember that you did on data sets that quick site visualization for extracting from effective business data the charts that
Yeah.
can give you a perspective. So can you unpack that a bit
What
on
part of it? Sorry.
storage? The
The,
storage to QuickSight, you remember that you converted storage data to analytics. So that is really coming out from the usage of the storage
yeah.
that is also a hidden surprise, not just an evident one. And to materialize data, you remember how hard was to convert what you had inside the storage, data in motion.
Yeah.
So it's
Those
something,
were those were
yeah,
big issues to deal with. I think this is one of the topics that's hard to lay out the journey at the beginning. Um, and a lot of these tool sets that we're talking about, both at the hyperscaler and at the more do it yourself kind of approaches, with EK or K3S, for example. I think what one of the things that you run into is both of them have limitations around network and storage, right? And it gets down to the complexity of the network and the complexity of the storage and how it's all laid out, and at some level how big it is. So on the observability side or the analytics side, when we were doing things, I think some of the stuff that we saw was that the scale of it all was pretty significant. And we ended up with not so much bursty relationships with a lot of the work that we did, like you'd have with GPU, but it was still um, a significant amount of information, and you needed it to land properly in data storage for the long term. So that became a production constraint, right? We would get into situations where we couldn't land the data for some instability on the storage side, for example, and we would end up with production problems related to the fact that we couldn't land the data there. So to me, this is one of the areas that um, is challenging, and for me, it's never challenging, or it's not as big of a challenge when you have a smaller deployment. It's really when you have something that's complicated where
and
this
cost
kind of goes off the
will
rails.
grow a lot
Yeah,
uncontrolled.
yeah,
So think about day two operations and site reliability reality, because these are where we land once we start from storage networking and we have this cluster life cycle. We are a cluster fund, so we have to talk about clusters. And we prefer blue green while rollback is safe, but we don't want really to roll back. We add-on drifts like pin versions, reconciling with GitOps, observability with the Prometheus, Thanos, Loki, Grafana, OpenTelemetry, a lot of names that are trendy today, and they are all available inside the cluster running Kubernetes. Then service level objective driven alerting that is coming from this kind of observability and is very important. It's not noise. Sometimes it can lead to false positives, so we need to really be careful to avoid generating additional traffic and uh, let's say operations from our team, day two operations, and the central monitoring hub across mixed cloud and edge. It's the real challenge there because you have to manage your own observability in these two contexts where networking and storage were the main guys there acting as a sort of spots for costs. And you said before that you, um, let's say, managing is doesn't mean no operations. So managing also is part of the operation costs. Um, I think that on day two and SRE and shift left, there are additional costs to consider. You think that costs for FinOps are hidden more than what we talked earlier?
Yeah, I mean, I think that the challenge is, you can like observability, for example. You can buy a service and it's going to cost money because it's transactional. And if you're successful, guess what? You're going to be spending more money on that observability than you planned. I think the challenge with it is understanding, you know, really not just looking at the financial cost, at the unit level, but looking at like what are you trying to get out of it? So in other words, you can put together a big observability platform from a service, but if you don't have the people and the time to make use of it, you can spend more money than you need to because you're really not in a position to like make use of even the service that you're buying, which is going to be more expensive. I think what we've learned over the years is that when you change gears on it and you go from service to roll your own on stuff like SRE capabilities, um, it's costly. It's very costly. It's not a direct production value proposition, but it racks up real cost trying to get to a place where um, you can look at things appropriately. But I think the reality is if you're successful at what you're trying to accomplish, like let's say with a platform business, your inability to troubleshoot effectively because you haven't instrumented observability enough is a tragic disaster for a lot of companies. You look at companies like Datadog who survived massive problems, just their entire network going down. Their ability to, I mean, they're an observability company. Their ability to like pull themselves out of that on their own and solve the problem, it's heroic. It's going to go down in history as one of the great accomplishments of people in SRE and ops, um, of people doing that kind of thing. Period. So to me, I think this all kind of rolls back into it's not all about money, but it is one of the things that we have to deal with if we're going to build these systems and have happy customers and pricing that's profitable and everything else. We've got to be able to plan it and then deliver it. And the inability to do that is extremely dangerous. It can endanger a company and really endanger a product. So there's this convenience tax to basically use premium everything and storage and control planes that are a service and somebody else's egress and cross traffic between providers to like game neutrality and survivability. Those are all great ideas, but they're also pretty expensive.
And in FinOps, costs are also uh, related to something that we call distributed systems.
That's right.
So, yeah, I think that we have that. I remember a sentence that was describing the edge mass that is 50 small sites with K3S nodes can beat one giant centralized cluster over wide area network. So the problem is that when you distribute too much, you can really lose control of the potential cost increase for all the network of these super powerful small sites that can beat the big one. In the big one, you just have to observe the cost for the resources that we were mapping earlier. When you have a lot of nodes and applications distributed worldwide, That is the reality because today we talk about agentic, the agent that is appearing there to do a task. And it's just a matter of time where agentic will be edge agentic
Hmm.
option. So at that point, you can imagine that if you don't have something like Kubernetes that is giving you the ability of tracking everything, it will be a problem for the pocket. That
Yeah.
is very complicated.
Yeah. I think, you know, this understanding of your business case, you know, around what your, you know, your APEC, your CapEx profile looks like, right? And being able to manage it as a template is probably the way out of this, right? Like you have to plan your edge out in such a way that you can reduce the unknowns about it, right? And you can think about it over time because your applications in a, for example, in a platform business are not going to just, you know, magically appear very quickly, right? So they're going to grow over time, then you're going to have more capability, then you start leveraging the edge more. So, you know, you need a plan that's going to move you from one thing that worked to another thing that worked. So you're going to need edge patterns, for example, and really distributed architectures that can survive over time and be modified to, you know, deal with the requirements that might grow in your system over time.
And again, there are patterns that I would like to mention very briefly about the edge case, where you can use something like store and forward queues, local caching policy enforcement. You can also sync and reconcile jobs to core. This is how you start small with K3S, so small nodes, and then you grow to RK2 when compliance scale tightens. And at that point, resilience, autonomy, that are very important for business leaders in this case, not just for people that are involved in technology and IT. Because if you have a support call, we know that the engineers will be putting their hands, the DevOps team, the operation, the site reliability engineering, a lot of technologies that will solve the problem, but that service level agreement affected will be for business people. So costs are translating also from the bad patterns that you can use. And at that point, you have a decision to take that is generally what we talked about: latency, data locality, geo distribution, regulations, day two maturity and operations. I was talking about cost predictability, ecosystem dependency, offline needs, a lot of words that are describing basically a decision. This decision we translated earlier in RK2 plus edge versus cloud, but I would say now renegotiating that hybrid solution could work better, maybe. Do you think, Ed, that uh, when customers or business people are receiving the proposal of having a distributed system, where they will look at for a simple decision to opt where to go for?
Yeah, I mean, everybody's going to want to reduce the decision into something that can be written down. And from that perspective, it implies some simplicity, um, in that I think that you know, the decision is around the points that you're making, right? Regulatory burden, for example, that is a decision driver. And we talked about a number of other things that are going to influence you one way or the other. I think at the end, though, I mean, there may be some bias to one solution or the other, but you could oversimplify at the same time. I think that if you're actually looking at a journey of a number of years and a lot of growth in some kind of platform that you're talking about, all of these things go in different directions, right? It's unlikely, like if you were depending on like regulatory requirements for life science, that they're going to go away, but they're probably going to change and grow in intensity rather than shrink and get cut. Although I guess that's kind of a government decision. But I think, in the end, these things that are possibly predictable get, less predictable over time, right? They change enough that, a decision that you made in the beginning now it has to be changed, right? Because either you've done better than you thought and you've got a lot more like data flowing over networks and so forth, or you're, in a situation where regulations change and now you suddenly have to like do something different. So I do think that the points that you were making, like edge offline need, talent availability, these are all things that if we were going to like advise a client, we would be saying, okay, here's your decision matrix. Well, this is the decision matrix for now until you hit this amount of sales or this amount of data or this amount of time, and then, or this amount of regulatory burden. And then we're going to have to redo this plan again. And there'll be cost implications. And,
For sure.
I think the whole point though is that that's business, right? I mean, you're building this to accomplish something. It doesn't have to necessarily be making money, but a lot of times the more successful you are, the more cost you can expect to have to incur.
I think that is generally related to life. Now we are talking about um, business, technology, but the negotiation and renegotiation is always related to being alive. A dead cluster will not produce costs. A dead man will not cost, unless in the cemetery they will bill you for something. So, let's say not a dead cluster, but something that is left there. So I would think about a summary of three references for resuming what we were talking about, the cloud core plus edge K3S that is good for solutions like cloud AI, data, and then K3S at sites. That could be a first blueprint. Then we had RK2 everywhere that is more on the cloud because remember that RK2, when you think about that, think about cloud
Yeah,
option. It's optimized for the cloud, not at the edge, and it's a baseline that you can consider hardened, and it's having rancher options, synchronization to core, and similar. And then you have this hybrid data gravity that I would always consider as something that is the right compromise, not being stuck with something that you want just to use and you say, okay, this name is what I like and I will do that until the end. But being flexible and consider that hybrid data can be also a way of having in cost multiple banks accounts because you have several services like the credit card that is zero in a bank account and in the other place is double. So you can use services from where you need. And I think that that will drive the business to be, let's say, coached by consultants, us in this case, to choose the right option for each small case.
that's right.
So, yeah,
Well, so with a few minutes left, let me run by some kind of anti ideas or anti patterns um, to talk about, and just give me your quick impressions on it. So instead of distributed architecture, one giant multi-tenant, one cluster to rule them all solution. Which,
terrible.
how do you feel about that?
Very bad. It's like the monolithic application. Then we went to microservices. Today we have distributed system. Never put your hand on one giant multi-tenant cluster because the killer of giants will come. And then it's not just like a song, but
True.
we will have the problem with that.
Mesh. So mesh installed. I mean, because it's a
Oh,
cool
no,
thing. I
no.
mean,
You mean meshing? Yeah, no, no,
yeah,
I don't think it's good always. It can be good, like in example, when you want to create a service mesh, something that is available in several ways from air gap things. In Kubernetes, you do that with Linkerd or ECO. It's okay, but it's not because it's cool. So I have the mesh, I have my service mesh. If I don't need to mesh a service and I just use an endpoint, please
yeah,
don't introduce additional complexity.
yeah. I know how you feel about all these, but I'm going to ask you anyway. So no GitOps, just Snowflake every cluster. Does that sound like a good idea to you? I mean, maybe if you
Today,
had like 3 clusters, that's that's okay.
today,
But if
no,
you had
GitOps
300,
means
I don't know if that's a good idea.
full of snowflakes. Then we can
Yes.
call Santa Claus because snowflakes is in December and the present that will bring us is a disaster. Because without GitOps, we don't have the way to do CI CD correctly. So the operations in Git with the source of truth, where you effectively have the developers and that are everyone that is doing a practical activity on top of the technology will be impossible. I mean, you have to implement GitOps.
Well, let's move to wrap up. We're closing in on the hour here. So some things that we could give, without handing somebody something, and you're welcome to go to our website, and our website's plural, and look for all sorts of information, including other podcasts that you could listen to. But I think, I think there's a couple of ideas we could leave our clients with, as far, or potential clients, or people that are just interested and want to try to do some things. One would be to get a baseline of 90 days of utilization, um, including everything, egress, GPUs, and so forth. And
Try and buy.
do what? What was that?
Try and buy 90 days. Don't
Yeah,
go
yeah,
for 91.
yeah. I mean, if you could get that baseline, you could start to figure out, the rubric and how to make a decision on it. What are some
Yeah.
other ones you could come up with?
Since you mentioned GitOps, I would say convert one environment to GitOps for starting if you don't use
Yeah.
it, and it will be healthy for your service level objectives because you will have effectively the hands in control for the operations. Then one other one, but one could be one managed cloud site, one KGS or K2, wherever on the cloud or at the edge, but with management, something that you can really see. For that reason, we mentioned the load rancher. If you
Yeah.
don't manage your Kubernetes cluster, in the theory, you will just use kubeadmin. But I don't know companies that are running kubeadmin, Kubernetes, the base distribution for their business, because I think it's quite complicated. You have to implement a lot of logic. And then we talked about networking and storage. People need to think about locking it. So the network, the right CNI, the topology. Do you want to use the VPN? You don't. You prefer to use mesh. You want to use your storage for object storage or for cold storage. Please plan. That's very important. We have to lock networking and storage together.
Before we go, if we haven't talked about it before, explain what that jacket is that you're wearing and what those buttons are for
This
all
is
our
cluster funk
Kubernetes
in
friends.
action without the bass and the guitar. They are there, both the guitar and bass. But basically, this is the jacket that you get when you are certified in 5 special abilities for Kubernetes that will give you the title of Kubestronaut. You don't go to the space, but you are floating in the Kubernetes space.
I thought you went in space, so I thought that was
Yeah,
part of it.
but that is betraying me because the background is my office. It's not space. So, yeah, but they gave me this jacket that is very nice to have. I also added additional certifications. So I'm going for another level of Kubestronaut that is the golden one, 13 or 14 certifications altogether on Kubernetes, on Linux, and on whatever we like to work at Veritas Automata. And on this side, I also have the nightmare of every developer and the site reliability engineer. Pager duty, you are on call. So this jacket is describing my life basically
It's
in
it's
the
a great
last year.
it's a great jacket. We should all bow down to it because it was hard fought. I remember when you got it, you were
It
like
was
one of the
without
first.
pins.
Yeah, but you were like one of the first people to get one. You
In
were
Colombia, yeah, I was the seventh, I think.
there. You go. So anyway, thank you to all our listeners today and anybody who picks this up in the future. This is Ed Fullman saying goodbye.
And this is Fabrizio Sgura saying, let's go for more cluster fun.
That's right.
See you next
Thank you
time.
very much.